Okay. So, today I'll be starting with the activity series. We can probably go through that fairly quickly. Then we will hit up the redox reactions, balancing redox reactions, which will take quite a bit longer. And once we've finished both of those, we'll have finished Chapter 7. So, chemical activity. Activity can mean different things in different contexts. In this context, what we mean by chemical activity is how much something wants to be oxidized. Right. So how good a reducing agent the substance is. Okay. So typically we're talking about this in terms of metals, but we can include pretty much anything on an activity series. An activity series is just a ranking of substances based on their activity. So here we have a list of a bunch of metals in an activity series. Higher up on this list means that they more want to be oxidized. Lower down means they don't want to be oxidized. So up here at the top, we have lithium. Lithium is a very, very active metal. Really wants to be oxidized. You drop lithium into cold water and it will react. Come a bit further down, you have, say, aluminum. Okay, aluminum is still fairly reactive, but nowhere near as much as lithium. You drop aluminum into cold water and it does not react. You would have to drop aluminum into boiling water or steam in order for it to react with water. Come even further down to, say, tin. Tin will react with water. Not so much. Tin is not that great at reacting with water. Come even further down, and these things won't even react. Tin would have to react with an acid, not even steam. Okay, only an acid. Come down here to these guys. These guys won't even react with acid. Okay, so you see we have hydrogen here, hydrogen gas going to H plus and 2E minus. Okay. We use that as kind of a standard, things we can compare it to. Okay. So there is the list of things that will react with cold water. Those things there will react with steam, but not cold water. These guys will react with acid, not even with steam. These guys won't even react with acid. So we can use the activity series. Yes, Max. Jason. Lithium is the metal we use in batteries. And that's why we use it in batteries. It's cheap and it's powerful. All right, so we can use the activity series to predict reactions. Okay. Combine a metal with an ion. Okay. So a metal that has already been oxidized and a metal that has not yet been oxidized. Okay. So, for example, we have lithium here, lithium metal combining with gold ions. So this is a redox reaction, so they're exchanging electrons. So lithium is losing electrons, gold is gaining electrons. Will this reaction occur? So the way you use the activity series is you compare the metal with the ion. Okay. So this metal here, lithium, is up top, gold is way down here at the bottom. So if the metal is above the ion, then the reaction will occur as written. So lithium wants to be oxidized, gold does not want to be oxidized. Lithium is up here, it really wants to be oxidized, gold does not. So this reaction, as written, really conforms to the way these two want the world to be. Then we come down here to this one, chromium and barium. Chromium metal and barium ion. We see chromium is right here, and barium is up here. So that means that barium wants to be oxidized more than chromium does. Therefore, this reaction will not occur as written. Okay? Barium does not want to be reduced. Okay? Chromium does want to be oxidized. Okay? All these metals want to be oxidized somewhat. Okay? It's just a matter of which one wants to be oxidized more. Barium wants to be oxidized more than chromium does. If we were to reverse this reaction, then the reaction would occur as written. Okay, chromium and barium, the chromium ions and barium metal, would proceed to chromium metal and barium ions, but not the reverse. So, go ahead, take a second, take a minute. For those of you watching this later, go ahead and pause the video and then come on back. And welcome back. All right. So will these reactions occur as written? Copper metal and sodium ions. Is copper above sodium? Here's copper down here below hydrogen. And here's sodium way up here. So no, copper is not above sodium. Therefore, this reaction will not occur as written. Iron and cobalt. Is iron metal above cobalt, the ion? Well, here's iron, and just below it we have cobalt. Therefore, yes, that reaction will occur as written. Iron wants to be oxidized more than cobalt does. Now, lead versus magnesium. Lead metal, magnesium ions. Here's lead, and here's magnesium. Lead does not want to be oxidized more than magnesium does, therefore this reaction will not occur as written. Manganese metal and tin ions. Here's manganese, here's tin. Manganese is above tin, therefore this reaction will occur as written, yes. Now, copper and silver. Copper metal, silver ions. Copper, silver. Okay. Copper is above silver, therefore copper wants to be oxidized more than silver does, so this reaction will occur as written. Okay. So no, yes, no, yes, yes. All right. So like I said, all of these tables are going to have hydrogen somewhere on them. Hydrogen is our 0 point. Okay, batteries. This all comes back to batteries. Okay. Each of these written here on the right is a half reaction. Okay. We never really include electrons in our chemical reactions, only in half reactions. So each of these shows the oxidation portion of a redox reaction. Okay, oxidation and reduction always happen together. Each of these is just the oxidation portion. And you can't have half a reaction by itself. So the way they started ranking these, comparing these, was they just used hydrogen as the neutral point. Because it's really easy to just drop a metal into acid. So they were able to start comparing this to hydrogen, then they were able to compare them to each other, and so on. And when you continue with this, if you were to take chemistry, second semester, you would see that in addition to just this ranking, we also put numbers to it. And those are the voltages that we get on batteries. So hydrogen is the arbitrary 0 point that everything else is compared to. So that's why hydrogen is the only non-metal included on this list. Now, when it comes to the test, they're going to have to give you an activity series. They might give you a short, quick, abbreviated activity series for a specific problem, or they might include a table like this one. I just grabbed this one off the interwebs. But either way, they'd have to give you a table. I don't think you can memorize a full table. I mean, it'd be really easy to say lithium versus gold, but not so much zinc versus magnesium. So I don't think that they would expect you to memorize the activity series. I do expect them to expect you to be able to use an activity series. Just remember, higher up wants to be oxidized, lower down does not want to be oxidized. That's how you use the activity series. So, before we go on to talk about balancing redox reactions, which is going to be much more hideously awful, here is just a pretty picture. This is what happens when you put copper metal into a solution of silver nitrate. The copper gets oxidized, the silver gets reduced, and thus you see that the copper has entered solution, turning it this pretty blue color, and the silver has started to accrete onto the surface of the copper wire. And if you take the time to bend the copper wire into a Christmas tree shape, you get this pretty looking tree. All right. Now, unless there are any questions, then that is going to be it for this particular set of slides. Yep, yes it does, Jess. All right. So, since it would appear there are no questions, I am going to go ahead and call it for this slide. I'll take a 5-minute break, and we'll be back in a few with balancing redox reactions.